Okay, so 10.4 is going to be the last section that we're going to do in chapter 10, and it's all about areas of circles and sectors. So the area of a circle is pi r squared. And just like when we were talking about circumference, you can leave answers in terms of pi, meaning you want that symbol pi in your answer, or you can round it to the nearest whatever, 10th, 100th, 1000th. Again, if you're rounding to a number, you're always going to use the pi symbol on the calculator. The only time that you can use 3.14 is if the question explicitly tells you that you can use 3.14 for pi. So again, we'll start out with the basics and then we'll build on that. So we want to find the area of the circle to the nearest 10th. So again, the area of a circle is pi r squared, and right away we know what the radius is here. It's 2.8, so we're going to have pi times 2.8 squared. Okay, again, it says to the nearest 10th, so we are going to hit the pi key in the calculator. Again, you can enter this all into the calculator at once. You can just hit pi times a set of parentheses 2.8 squared and hit enter, and it will give you the right answer. Okay, when you do that, this should come out to an answer of 24.6. Again, please make sure that you're playing along in your calculator and getting the same answers as me. Okay, the other option for the area of a circle is if they gave you the diameter first. So again, we want to find the area of the circle. This time we want to leave it in terms of pi, meaning that we need pi in our answer. So again, we're going to do pi r squared. The only problem is this time they gave me the diameter. So to go from the diameter to the radius, we have to divide by 2. So 58 divided by 2 will give you an answer of 29. So that means that your radius is going to be 29. So we're going to have 29 squared times pi. Okay, and again, I'm going to square 29 in the calculator, but I'm not doing anything with that pi symbol. We want the symbol pi in the answer. So 29 squared is 841. And again, we'll tack on that pi, and that's going to be your final answer in terms of pi. Okay, so Central Pizza offers 2 sizes of pizza. How many more square inches to the nearest 10th is the large than the medium? Okay, so what we're going to do here is we're going to find the area of the large and the area of the medium, and then we'll subtract them to see what the difference is. Again, difference means subtract. Okay, so the area of our large pie, okay, again, is going to be pi r squared, and our large, it's a 15-inch diameter, which means that the radius there, if I divide that by 2, is going to give me 7.5. So that's going to be pi times 7.5 squared. Again, it says to the nearest 10th of a foot, so we'll use the pi key on the calculator this time around. So you're going to do pi times 7.5 squared. And when we round that one to the nearest 10th, you're going to get 176.7. The area of your medium, again, is pi r squared. And again, this time my diameter in this case is 12. So the radius, 12 divided by 2, will give you an answer of 6. So we're going to have pi times 6 squared. And 6 squared is 36. So if you just want to type 36 pi into the calculator, either way that you do it, you should, when you get around to the nearest 10th, is going to be 113.1. And again, we want to know how many more square inches the large one is, so we're going to subtract here. So we'll take the area of the large, which is 176.7, and subtract out the 113, which will give us an answer of 63.6. So 63.6 is going to be your final answer there. Okay, so here we have a shaded region question. Just like in the last section, shaded region, you're going to take the area of your larger figure and subtract out the area of your smaller figure. Okay, so it says in the diagram, triangle ABC is inscribed in circle M such that AMC is a diameter. The radius of the circle M is 13 and the length of BC is 24. And we want to determine the area of the shaded region to the nearest whole number. Okay, so they told me that BC is 24, so I'm going to put that in. And my diameter is 13. Okay, I'm sorry, it's not the diameter. The radius of the circle is 13. So that's only half of that. So the radius of the circle is 13. Okay, so again, area of the shaded region, the area of the larger figure minus the area of the smaller figure. So which one's larger? The circle. So we're going to do the area of the circle minus the area of the triangle. So again, the first thing I'm going to do is replace those two things with their formulas. So the area of a circle is pi r squared, and the area of a triangle is the base times the height. Again, we were told what the radius of that circle is. It's 13, so I'm going to have pi times 13 squared minus 1/2, and now I need the base and the height of that triangle. Well, 24 is going to be the base, and right here, the AB is going to be the height of that triangle. So now I'm missing the height of that triangle. Okay, well, to find the height of that triangle, I can use the Pythagorean theorem, and we just need to be careful when we do it. This entire length of AC, remember you were given the radius of the circle. AC is the diameter, which means the diameter there is going to be 26. So the full side of that triangle is 26. So we'll do A squared plus B squared equals C squared. Again, the only thing that matters is what's going in for C. That side opposite your right angle is going to be 26. So you're going to put 26 in for C. And I'm looking for either A or B. Again, it doesn't matter the order that you go in. And we'll put 24 in for the other missing piece. Okay, so 24 squared should give you an answer of 576. And 26 squared is 676. Subtract 576 from both sides. And you're going to get x squared equals 100, square root of both sides, and x is going to equal 10. So that means that the height of your triangle is 10, so we can chuck that into that formula now, and now we can plug and chug here. So again, inside the calculator, since it says to the nearest whole number, we'll do pi, the pi symbol on the calculator, times 13 squared. And when you do that, you should get an answer. I'm going to round it to 2 spots for the time being, of 530.93. And on the right, when you do 1/2 times 24 times 10, you should get an answer of 120. So when you subtract, you're going to get approximately 410.93, and which means to the nearest whole number that's going to be 411. It's going to round up to 411. Okay, so now we're going to have the sector of a circle. So the sector of a circle is basically like a full slice of pizza pie. Okay, so it's a region bound by an arc of the circle and the 2 radii to the arc's endpoints. So again, this pink shaded area of that triangle is a sector. Okay, and it's called sector EOD in this case. So the area of a sector of a circle is going to be the arc divided by 360 times pi times the radius squared. Okay, so really the only difference between this and if you remember the length of an arc is this piece right here. Remember the length of the arc had pi times the diameter directly related to the circumference. This has pi r squared, which is directly related to the area of a circle now. Okay, so let's take a look at this in a question. For 5, what is the area of sector ACB? And we're going to leave our answer in terms of pi. Okay, so again, in terms of pi means that we want that pi symbol inside of our answer. So again, we're going to do the arc divided by 360 times pi r squared. So the arc, again, if the angle is 45, that's a central angle. That means that your arc is also 45. So you're going to have 45 divided by 360 times pi, and your radius here is 12. So you're going to have times 12 squared there. Okay, again, on the top, I'm going to do 12 squared times 45. Again, we want pi in our answer. So we're just doing 12 squared times 45. That's going to give you an answer of 6,480. And we'll tack on our pi symbol. And then we're going to put that over 360. Again, we want to reduce that fraction to simplest form. The first thing I always like to do when I'm reducing a fraction is first just divide the two numbers to see if they go in evenly. Because I have no idea off the top of my head if 6,480 is divisible by 360. But if it is, then I don't even have to worry about what number goes into both the top and the bottom. And it turns out that 6,480 is divisible by 360. It's going to give you an answer of 18. So 18 pi is going to be the area of that sector. Find the area of the shaded sector to the nearest hundredth if BC is 8.1. So again, we're going to do the same thing here. The only difference between this and the previous question is now we don't want our answer in terms of pi. Now we want it to the nearest hundredth. So 2 spots after the decimal. So again, we're going to do arc divided by 360 times pi r squared. Again, if your central angle is 51, that means that your arc is also 51. So we're going to have 51 over 360 times pi, and your radius here, BC, they told you was 8.1, so we'll have 8.1 squared. Okay. Again, as with the length of the sector, remember this technically you're finding this in terms of radians here, so that's why we're using that formula to begin with. So again, you can chuck this all into the calculator. If it's me, I'm going to do 51 times pi times 8.1 squared, hit enter, and then divide that answer by 360. No matter how that you do it, in the end, you should end up with an answer of, it comes out to 29.2 or 19 point something. It's going to round to 29.20. I forget what it comes up in the calculator exactly. I rounded it on my paper to begin with, but just be careful of that one. To the nearest hundredth, we have to go 2 spots after the decimal, which would be 0.20, sorry. Okay, and 7, this is going to relate back to a question like in section 10.2. Okay, so in a circle with a diameter of 32, the area of the sector is 512 pi over 3. Find the measure of the central angle. Remember, the central angle and the arc are congruent. They're the same thing. So if I can find the measure of the arc, that means I found the measure of the central angle. So again, they gave me the area of the sector. Well, what do I know about the area of a sector? I know what the formula is. It's the arc divided by 360 times pi r squared. Hey, again, I'm looking for the central angle, but again, the central angle is going to be equal to the arc, so I'm looking for the arc. So I'm going to call that arc x. Again, I'm going to put that over 360. I'm going to multiply that times pi. I was told the diameter is 32. Hey, if the diameter is 32 divided by 2 should give me an answer of 16, which means that 16 is going to be your radius, so I'm going to have 16 squared. But I know what I have to get when I figure that out. They told me in the problem. When I do that, I should get an answer of 512 pi divided by 3. Okay, so now we're just going to clean this up a little bit, just like we did in 10.2. I want to end up with 2 fractions set equal to each other so I can cross multiply and solve. So on this left-hand side, I'm going to do 16 squared, and 16 squared is going to give me 256, and then I'm going to tack on my x and my pi. Okay, and again, all of that is going over 360, and that's going to equal 512 pi divided by 3. And now, again, I have 2 fractions set equal to each other so I can cross multiply and solve. So 256 times 3 should give me an answer of 768, and tack on your x and your pi. And when I cross multiply the 360 times 512, 360 times 512 is going to give you 184,320, and tack on the pi. So this x is what I want to get rid of. So to get rid of that x, again, I'm multiplying x right now by 768 and by pi. So the opposite of multiplying by 768 and pi is to divide by 768 and pi. Whatever you do to one side, you have to do to the other. So over on the left-hand side, the 768s and the pi's will cancel, leaving you with x. On the right, again, those pi's will cancel, and now I'm just going to divide and make sure that they go in evenly, or if they don't, then we'll just round it. Hey, but when you do that on the calculator, it does divide evenly, and you're going to get an answer of 240, which means the measure of your arc is 240, which means the measure of your angle is 240. Okay, and again, this is sort of like a composite figure here. We want to find the area of the shaded region, and we want to round to the nearest hundredth. It's technically shaded region, so technically I can do the big circle and then subtract out the area of this sector 1 and this sector 2. Problem is I'm not going to be able to find those two arcs in order to find those areas, so I can't do that. Okay, but what I can do is I can find the area of that semicircle and the area of this sector over here. And if I add them together, that will give me the area of this shaded region. So we're going to do the area of the semicircle plus the area of the sector. So again, I'm going to take out those things now and replace them with their formulas. So the area of a semicircle, well, the area of a circle is pi r squared, and a semicircle is half a circle. So we'll just take that and divide that by 2. And the area of my sector is my arc over 360 times pi r squared. And now we'll just start plugging things in. So again, they gave me the total length of JM. JM is the diameter. So my diameter equals 10. If my diameter equals 10, that means my radius is going to be 5. So for my circle, I'm going to have pi times 5 squared divided by 2. On the right, the arc, well, if the central angle is 58, that means my arc is 58. And we'll put that over 360 times pi, and again, the radius isn't going to change here. It's still 5, so we'll have 5 squared there. Okay, so when I figure out pi times 5 squared and then divide that by 2, it's going to come out to 39.2699. I'm just going to push out a bunch of spots for the time being. Okay, and then we'll do the same thing on the other side. We're going to do 58 times pi times 5 squared. Hit enter, and then divide by 360. And when you do that, you should get 12.654. So now when you add the two of them together, you should get 51.9239. Nearest hundredth means 2 spots after the decimal, which means this is going to round to 51.92 in the end. And that is all for chapter 10.